Hello ladies and gentlemen, I recently did a video that you could do at home that showed that the full moon cannot be observable on a globe. Now, I got a lot of flack saying, oh, you didn't do it to ratio, that's why it didn't work. Well, I took NASA's numbers off their sites here, NASA fact sheets, for the sun, the earth, and the moon, and I took their numbers and I put them in a little chart here. Now, in order for me to do this to ratio, if I took the moon and the moon was 1 millimeter, then the Earth diameter would be 3.7 millimeters, the Sun diameter would be 400 millimeters, the Earth to Sun would be 43,000 millimeters. That's about 43 meters, folks. My room isn't that big. So that's why I didn't do it according to ratio. Now, I'm going to prove to you how I was right about my experiment. I took NASA's numbers and I made a diagram here. Okay? Shows the sun volumetric radius, as which I had to use, as on NASA's site, they do not give me a proper radius, as they do for the moon and the Earth. So, I decided I'd use the volumetric radius for both the Earth and the sun. Now, if you look on the Earth fact sheet, you will see the difference between the volumetric radius and the equatorial radius is almost nothing. So it doesn't matter in this experiment. And if you would like to argue with me, it's not going to matter. And I'll show you that later. Now, we have the sun, we have the distance to the sun from the Earth, we have the Earth's volumetric radius, we have the distance from the moon to the Earth. I also have the moon's volumetric radius, although it has no effect in this demonstration. Now, what I did is I drew a right-angled triangle from the center point of the Earth here, along the radius, to the surface of the moon and back, showing the angle of shadow being cast directly from the Earth to the moon. This is represented by this triangle here, with the Earth's radius as AB, and the Earth's radius plus the moon to Earth average as BC. Now I have to include the Earth's radius in BC, as we can see here, this would be the right angle point of the triangle. Well, this is still Earth radius, so I had to include it. So, I have all these numbers, and I use trigonometry to figure the angle that the shadow would be cast on the moon. I do tan of angle C, and I find out the angle is 0.93982 degrees, less than 1 degree angle. Okay, that's all fine and dandy. Now, I took another right angle triangle going straight from the sun, including the sun's radius, including the distance from the Earth to the sun's radius, and then another radius, because diameter is both. Diameter is the full, radius is only half. And then the distance from the Earth to the moon. That would be, as we see here, EF, written right there. And then DE would be just the sun's radius, as we can see here. It would just be right here to here, and then DF, which would be the sunlight path, would be right there. Now, by finding out the angle right here of the sunlight path, which, again, using trigonometry, I find out that the angle itself is less than 0.250897 degrees. Now, looking at that, the Earth shadow has to be smaller than the sunlight angle in order for the sunlight to be getting past the Earth. So what I did to further prove this is, and if you guys believe I did my corrections incorrectly, I double-checked the other angle of the triangle, and as we can see here, it adds up to 90 degrees, and for the solar one, it adds up to 90.161 millionths of a degree. and I'm doing all my calculations in tenths of everything. So that's literally infinitesimal. Now, to show what I'm proving, because the right angle triangle only does half of it, to get the full angle, I just double the angle of my answer to get from here to here to here. I get this angle. The same thing with the sun. This angle here to here. Now, by looking at these angles, I then multiplied them by 2 to get what I was just explaining. These are these numbers. We get the Earth's shadow is 1.87964 degrees, and the sun's light angle is 0.501794 degrees. That's less than a degree, folks. Now, to show you this in better observable formats, I multiplied both those angles by 10 just for this demonstration, as you can see here. Right here, this is the edge of the moon. I didn't go by the middle because the full side that's facing us has to be lit up, so it has to be hitting this edge. Now, as we see here, this is the Earth's shadow casted by itself. See the angle? And then we see here the sunlight angle. But in order for us to be properly observing a full moon, as previously demonstrated in my other video, this angle would actually be inside this, thus proving that the Earth would block out the sunlight, as we can see in this diagram right here. It is not possible, folks. You wanted me to do the math? You wanted to throw fancy NASA numbers at me? I've done the calculations. The angle of the sunlight would have to be bigger than the Earth's shadow angle in order for the light to still be reaching the moon properly. It doesn't work, folks. Good night.